So let's continue with 1-1. We'll call it 1-1b. So let's just go right to an example, all right? This is example 5 if you're looking in the book. And it says to solve. Because we're trying to find what x is. So 3. Guys, please stop. Equals 1 over x minus 1 plus 7 over x minus 1, x minus 2. This kind of looks like what we were just doing, doesn't it? Kind of. Except the denominator is a little bit different, right? Because you got the minus and the plus stuff, all right? But it's really no different than what we just did. I mean, the basic idea of this problem is no different than what we just finished doing, all right? If you want, it might make it look a little bit nicer. Thought I turned that to yellow, but that's all right. Let's try it again. There we go. So take a look. I don't like the denominators. That's obvious, right? So that's what I want to get rid of. So I want to find something that everything will divide into evenly. At least common multiple, right? That's what we call it. If I could grab this. Let's try it one more time. Oh, goodness. It's going to take me forever. Come on, grab it. There we go. I need some more room here, so I'm going to get it away from this solve thing because I need a little extra room. Like that? Okay, so now let's take a look. I've got an x minus 2, I've got an x minus 1, and then over here I got both of them. Remember that least common multiple thing I just finished doing? Okay, let's separate them. I've got this one, and this one. Well, so I picked the one that shows up. What shows up here down the bottom? An x minus 2, right? Does it show up anywhere else? Yeah, it shows up here. But it only shows up one time here, right? So I'm not going to pick two of them. It shows up once here. So what am I going to choose? So what is my least common multiple of my denominator? Well, so far, I've got an x minus 2. Agreed? And again, it shows up once here and once here. I don't pick them both. I just pick one of them. What else shows up? An x minus 1. Well, it shows up once here, and it also shows up once here. So how many do I pick? I just pick one of them. That right there is my least common multiple. What do I do with that least common multiple? No, not in the denominator.
Oh, you multiply.
Yeah, I multiply everything by my least common multiple, right? It's the same thing that we did on those problems that we just went over, except it's a little bit more involved because it's not just a 3 or a 2 or a x, right? It's a x minus 2 and an x minus 1, which really doesn't make things a whole lot more difficult, but, you know, it kind of does. All right, so I multiply that by my least common multiple. I multiply this one. I'll just write it up here. I should have spread these out a little bit so I had room to write. And then I multiply this. See what I'm doing? I'm multiplying everything by the least common multiple. Let's get rid of this. So now, doing that, am I going to just take all this stuff and multiply it by 3? No. I did it so I could cancel out my denominator. That's the whole reason that I did this step. Does that make sense?
Yeah.
So what cancels out here on this first one? The x minus 2. That's right. Look, there's an x minus 2 on the bottom, and what's on the top? Another x minus 2. So guess what happens with those? They cancel out. You see that? That's why we did it. Right? The whole reason we multiply by the least common multiple so we can get rid of the denominators. So we know they're going to cancel out. Let's just cancel them out. What about this one? X minus 1 cancels with this x minus 1. Right? What about down here? This looks like the most confusing one, but it's actually the best one because they both cancel out. Exactly right. That x minus 1 cancels with that one. This x minus 2 cancels with that one. Isn't that fun, just whopping things off right there? Yeah. So let's see what we have. Let's clean this up, make it look a little prettier, okay? So what do we have? You could, if you wanted to, go ahead and distribute right now, right? For some of you guys, you're able to do that. Some guys, it looks like there's too much confusion going on, So we'll clean it up just a little bit. So it's 3 times x minus 1 equals, what happens here? I just got an x minus 2 is all I have, right? And then right here, what happens here? Just plus 7. Right? You don't even need this in parentheses right here because nothing's being multiplied by it. So that really was helpful, wasn't it? It is easy now, okay? You went from something that looked pretty complicated to something that's pretty simple and basic right now, okay? So let's do this. What do we do here? Distribute. So I got 3x minus 3. Let's do a little simplifying here. What am I going to get over here? It's negative 2 plus 7. It's plus 5, right? What? Negative 2 plus 7. I just did negative 2 plus 7. Just arithmetic. Thank you. So let's get the x's on the same side. Subtract an x. Subtract an x. Let's get rid of that 3 right now. I don't want to bring everything down just yet. Let's move everything over. So I like to add a 3 here, add a 3 here. Well, what happens? Those cancel, those cancel. What do we have? 3x minus x is 2x equals what? 8. Divide by 2, x is 4. It's as easy as that. Okay? Now, on the next one, it's kind of like what we just did. It actually looks a little easier. But the answer we get doesn't really work. And you're like, well, how will I know if it works or not? Well, just plug the numbers in. X is 4, correct? So I can put this in here. 4 minus 2, right? You get a number, don't you? Okay, 4 minus 2 is 2. Put a 4 in this. 4 minus 2 is 3. You get a number. I know you don't know why I'm doing that right now, but in a little bit you'll see it. Then put it in here. 4 minus 1, that's 3. 4 minus 2, that's a 6. So yeah, everything's going to be fine. We could add them up. We could check it if we wanted to. But I'm saying that for a particular reason, all right? It's for this problem right here. And this is example 6. It's in the book. And it is this. It's 3x over x minus 1 plus, I think it's just a 2. I'm going to put it over 1. Is that all right? Equals 3 over x minus 1. This looks easier than the last problem we did, doesn't it? And it kind of is, until we get to the very end, okay, when we get an answer. All right, then we got to make sure something happens. All right, so let's see. I got an x minus 1 and x minus 1. It's just one of them, right? I just picked one of them, the x minus 1. So really what I'm doing is I'm multiplying everything by x minus 1. Multiply that by x minus 1. Multiply that one. Multiply that one. Agreed? That was easy. So by doing that, what happens? This cancels with that. That's nice. Nothing cancels here because you just got a 1. And this cancels with this. Look how simple that is. You're like, well, it's got to be harder. It's the next example. I thought all the next examples were harder, right? Okay, so I'll show you. I tell you what, I keep saying this. You can just do this in your head and write it down. Let's just do it right now, okay? You should get used to that. So 2 times x minus 1, what's that going to give you? 2x minus 2, because I distributed the 2 through that. Everybody good with that? That equals 3. It's really easy. 3x plus 2x, that's 5x, equals, add a 2 to both sides, you get a 5. X is 1. Now, before you circle it, I'm going to give you a big, huge hint. What is 0 divided by 3? 0. What's 3 divided by 0? It's undefined. Good. I'm glad you said that right away. It's undefined. Because you cannot do what? You cannot divide by 0. Doesn't work. Try it in your calculator. So you cannot have a denominator of 0. So if I would have circled, everybody's watching, right? If I would have circled x minus 1 and said x equals 1, that's my answer. But then if I plugged it in, what would happen? I would get 0 in the denominator, wouldn't I? So if I put 1 minus 1, I get a 0. Am I allowed to have a 0 in the denominator? So does 1 work? So there is no number that works. Okay? If the number that we came up with doesn't work, then no numbers work. Okay? So you could say undefined. we usually say no solution, okay? Or you could say like the null set. Have you ever heard of that? N-U-L-L. It's like this. Sometimes they'll put a 0 with a little mark through it like that, or sometimes they'll write it as a set with nothing in it. Not a 0, but just nothing in it at all, okay? They basically mean the same thing. Null, N-U-L-L. You ever hear the phrase, it's null and void? Anybody heard that? You never heard it? Well, listen for it. You'll hear it in your life. A contract is null and void, right? You did something to make your contract not, I don't know, to make it null and void. That's all I can think of. All right, so anyway, so I'm fine with no solution. I'm curious to see what the book says. What does the book say? Let's look in the back. This is, I just look at the example. What do they say? It just says it has no solution. That's what it says. So I'm good with that. That's what I said anyway. So I would just say it's no solution. But you got to be careful with those. On that last one that we did, you remember when I put the x in here and I said, 4 minus 2 is 2. That's a number. Probably thinking, yeah, well, they're all numbers, aren't they? Well, 0 is a number too, but you can have a 2 in the denominator. If I put a 4 in for this, 4 minus 1, that's a 3. Are you allowed to have a 3 in the denominator? Sure you can, okay? But you cannot have a what? 0 in the denominator. So you got to make sure that you check your answer. You don't have to do the whole entire check. Just throw it into x if it's in the denominator. Make sure the denominator does not come out to be a 0, and then you're good to go. That was the only thing tricky about that problem. Okay? Let's do one more. I got 6 minutes left. Here in America, we are very stubborn people, okay? Of course, people in other countries are stubborn too, but I think Americans are more stubborn than any other country. And the one reason that I would give is because of the metric system. The whole entire world, I mean the whole entire world, uses the metric system. I lived in Australia in 1973 and 74. Okay, that's how old I am. Okay, I was 8 and 9 years old, and they were just starting to get into the metric system. Okay, they were started. The gas. I remember going to a gas station. It wasn't in gallons anymore. If it's in metric system, what do you think they sell it? If you go to Canada, you'll see this in liters, right? They'll show it to you in liters. Okay, liters considerably smaller than a gallon. But they started doing liters. They started putting the road signs instead of miles per hour. I remember guys taking the old signs out, putting new signs in. Okay, that was in 73 and 74. They were completely changing everything. It's 2022, and America still has not changed, okay? Now, we are used to some things, though, right? Like if you get a bottle of soda, right? What's the most common bottle of soda in your refrigerator? Like a 2 liter. So we know what a 2 liter is, right? We know what a liter is. When I go hiking, when I go hiking, I carry a 1 liter smart bottle, and that's what I put all my water in, okay? So I know instinctively like how much a liter is, right? How much a 2 liter is. So we know metric system. It's just there's a lot of things we haven't converted back over to. If you look in your car on the mileage thing, if you look in there, if it's not digital, and even if it's digital, there's a button you can click, right, to make it go to metric, right? But even if it's not digital, even if it's just a dial like this, you'll see the big numbers usually in white or something, and that's miles per hour. But you'll see the numbers a little bit smaller, maybe in a different color, maybe in an orange or a yellow or something like that. And then it says km. And what is the km? It's kilometers per hour, and they show it. So we do see it all around us, don't we? We just haven't converted. Like our football field is, how long is a football field? 100 yards, that's right. Now, so we are still staying yards, right? Track and field, though, when I was in high school, I ran the 3,200 yard race. Okay, 3,200 yards. We just call it the 3,200. But now they call it the 3,000 because it's what? It's meters. Okay, so it's 3,000 because a meter is a little bit bigger than a yard. So even in track and field, they've gone over to meters, right? The 100-meter dash. They don't call it the 100-yard dash anymore. They used to call it that back in the day because it was 100 yards, but now it's 100 meters. So we see it all the time. Well, what about temperature? That's what I'm getting at. What about temperature? What do we measure temperature in America? In Fahrenheit. Okay, what does the rest of the world measure temperature? In Celsius. Okay, so there is an actual formula. Now, this used to be a lot more relevant than it is today. Because today, and this is what I would do, to be honest with you, I would just go on Google and I would just put, what's today, like 35 degrees? I put 35 degrees Fahrenheit, and then it automatically knows what I'm putting in there, right? It would say 35 Fahrenheit to Celsius, and it would tell me what it was, right? But how do they get that? What is it, 17? So 17 Celsius if it's 35 degrees out, okay? So how, and let's use that. Since I just came up with that number, let's is it 17? It's not 17. 17 Celsius is warm. It's really hot. Somebody punch it in. You got computers here. 7? Is that what you said? Okay. So watch. 5. Here's the formula to change it if you didn't have your phone on you and your life depended on you changing it from Fahrenheit to Celsius, okay? Here's how you do it. That's the formula right there. What does the C stand for? The Celsius temperature, and obviously the F is the Fahrenheit temperature. So let's do it and see what...
It's 1 degree Celsius.
Okay, that's what I was thinking. I was saying it's a lot closer to 0 than anything. So 17 is very hot, yeah. Yeah. I mean, it's very warm. It's not hot, but it's warm. So watch. I want to find what it is in Celsius. And my Fahrenheit temperature is 35. Let's see what it is. It's 5/9 times the Fahrenheit. What's my Fahrenheit? 35. And then I subtract a 32. Where do you think they get that 32 from? It's freezing. That's right. It's freezing. So watch. It's 5/9 times what? What's 35 minus 32? It's 3. Okay. So let's see what we get. This 3, or this, 3 goes into this what? 5. It goes 3 times. So what is it? It's 5/3, but that's a weird number. In this situation, this is where we want to change it to a decimal, right? So it makes more sense to us. So what is it? It's 1 and what? 2/3, or what? 1.6. So if it's 35 degrees outside, which is probably pretty close right now to 35 degrees, what is it in Celsius? It's between 1 and 2 degrees Celsius, okay? That's how you do it. So you are doing this for your homework. Did you already collect it?
We already collected our time. I know.
Yeah, collect it from everybody else. Give your homework to Bianca. So 43 to 63 is the second part of this homework. That's your homework right there. Everybody got it? 43 to 63.